Okay. Hey guys, and welcome to naming acids and bases. This would be one day of notes, but we're going to break it up over the course of a couple of days to kind of ease off on the workload. So you're welcome and get excited. A couple things you'll need here for today is you're going to need that ion list on the back of the periodic table. Also helpful to have a bare blanket, but not necessary. So with that said, let's get started here. Now, as you'll see on this next slide here, I've got a bunch of different ions. And kind of the goal is, can you name those ions just by finding them on the periodic table and kind of jotting down what are the names of those ions. So if you want to, take a moment and try and remember, hey, how do I use that back at the periodic table? Can I find the ions? Okay, pause it if you need more time. Here are the names of the ions. We've got nitride, nitrate, oxide, chlorite, chlorate, sulfate, and sulfite. Now, the reason why I had you guys look up all these definitions is not because I enjoy busy work, but because if you look at the parts here, the endings that are underlined, you'll see that there are really only three different endings here. You've got IDE is one ending, we'll call that IDE. ATE is another ending, like nitrate or chlorate or sulfate. And then the other ending you'll see is ITE, like sulfite or chlorite. It turns out that all negatively charged ions have those three endings, either IDE, ATE, or ITE. So moving on to the next slide here. Here are the things that I want you guys to know for the end of the day. So for the end of the day, you'll need to know that acids are formulas that begin with H. Bases are formulas that end with this OH, which we call a hydroxide. And then the three rules for naming acids are if it starts with 8, you change it. So instead of nitrate, it would be nitric acid. That's the name of if you have NO3 and an H in front of it. HNO3 is nitric acid. If it's NO2, NO2 is nitrite. So it would be nitrous acid because ite goes to us and then you add acid at the end. If it's just regular N, regular HN would be nitride. So put an H in front of it, it becomes hydronitric acid. So if there's an ate ending, it's ic acid is how the ending changes. Ite, it's us acid. Ide, it's hydroic acid. For bases, the rule is very simple. You just name the metal and then you name the nonmetal portion of it is always going to be hydroxide. So you name it hydroxide. So let's say you had something like NaOH. Na is called sodium, so it would be sodium hydroxide. NaOH, sodium hydroxide. The one base we're going to teach you about that doesn't have an OH ending is NH3. We're going to call that ammonia. So get excited for that. Those are all the rules you're going to need to know over the next couple of days. But like I said, we'll kind of space it out just so that the workload's a little bit easier on you guys. Great. Let's start with ate to ic. So here is how it works. You'll see the examples down below here. You'll see HNO3. That's a prime example of an acid right there. You know it's an acid because it's got an H in front of it. So what you're going to do is you're going to keep the stem of the anion name, the nitr portion of it, and then you're going to just substitute out the ate for an ic. And then you're going to put the word acid. So if we were just to name this kind of like based on what we know, H is hydrogen, NO3 is nitrate, that's not the final name. That's just kind of like splitting those two up into like what their names are. So to turn this into an acid name, what we do is nitrate becomes nitric, and then the hydrogen part, that just tells you that you have an acid. So nitric acid is kind of the ending name there. For PO4, you might be able to guess that PO4 is phosphate. So you'll be able to see it'd be hydrogen from the H, and then phosphate. So the ending would be phosphoric acid. Notice in this case, the fact that there's a 3 next to the H does nothing. It doesn't influence the name at all. The only thing we're looking at when it comes to acid rules is the ending ATE. If you're looking for a fun way to remember this, I have the phrase I ate. In lunch today you ate something and it was icky. So ate kind of goes with ick as in gross. I don't know. Maybe that works for you. Maybe it doesn't. Don't care. It's a way to remember it. So let's move on to acid rule number 2. Ite to us. Name of the anion ends in ite here. So for example, NO2, that's going to end in ite. The punchline here, the way to remember it is, if you get into a fight, don't be a wuss. Don't condone fighting. Moving on here, hydrogen and nitrite is kind of what you do if you break those two up. Again, remember that's not a final answer, that's just a way to split them up. So then ite becomes us, and it's nitrous acid. With SO3, SO3 is hydrogen sulfite. Again, this is the kind of the progress name, and then the final name that you would actually write down would be sulfurous acid. You don't have to write down this stuff in parentheses here. I'm really just including that to be helpful, to kind of show you where the root comes from and where we change the stem. That's my goal here. And then again, notice here, I've got 2 H's, but the fact that I have a 2 next to the H does not add anything or subtract anything. It doesn't change anything in any way here. Just the sulfate, or the sulfite, I guess I should say. Okay, now these acids will be the smallest in terms of formulas, but they will end up having the largest names. Now we're talking about ide goes to hydro, ick, and then acid at the end. So if you have an anion ending in IDE, you need to add first hydro to the front, and then add ick to the end, and then put acid at the very end. So H and F, H stands for hydrogen, F stands for fluoride. By the way, here the phrase is don't hide, be hydroic, like heroic. I don't know. I'm yet to come up with a good one for that. So if you have a better one, feel free to shout out what you think that is to your computer screen, or like send me an email. Whatever you want. Hydrofluoric acid is the name here. So you'll see that I replaced the ide in fluor. I got rid of that, and then I added an ick to the end, a hydro to the front, hydrofluoric acid. Kind of cool. With H3P, again, the 3 does nothing here. So it's hydrogen and phosphide. So we're going to have to keep this phosp kind of base, and then we'll change the front, we'll change the back, and this will become hydrophosphoric acid. Something that you'll notice here with phosphide is that it's not just the phosp, we also add an or. In the same way that, like, for sulfide, it wasn't just sulfic, it would be sulfuric. You would add the UR to it. That works for phosphorus and sulfur. You kind of have to change them a little bit. Oh, if you look at the next slide here, here's something that's kind of fun. If I were to give you bromic acid, would you be able to work backwards and figure out what its anion name would be? Ick goes to what? Absolutely right. Ick would go to 8, so this would mean it would be bromate, and then you'd have to find a BrO3 1-. And then since I've got a 1- here, that means I put 1 H in front, so it's HBrO3. So something to keep in mind here, bromic acid, nowhere in that name is it going to tell you how many hydrogens you mean. Remember, we just ignore that part. So you're going to have to then, once you figure out ick goes to 8, find bromate on the periodic table on that ion list, and then realize, oh, it's got a -1. That means I need 1 hydrogen. If it had a -2, you need 2 hydrogens. -3, 3 hydrogens, so on and so forth. So we'll also ask you not only to go forwards, but also to go backwards. So be aware of that. And then up here on the top here with the bullet points, I've got kind of the rules, which is pretty much what I just said. So write those down. That'd be solid stuff to write down. Okay, here are a bunch of examples. Go ahead and pause this video and take a stab at it. Great, let's go over them. Hydrochloric acid. You'll notice it's got hydro and ic in the front. So this would be chloride. Chloride is Cl, and then it's Cl1 minus, so just be HCl. Difference here, chlorus acid for the next one. Us, when you're in a fight, don't be a wuss, so that's going to be chlorite, which is ClO2, 1 minus, so that's why I only have one H there. Acetic acid, that sounds like it's going to be acetate. Acetate is C2H3O2 and 1 minus again, so you just have one H in that final answer. Hydrosulfuric acid, you see a hydro here, so you're thinking, oh, this is as short as it can possibly be. Sulfur is just S2 minus, so here, that's why I'll have two H's in front of it, H2S. Difference between hydrosulfuric acid and just regular sulfuric acid is ic goes to 8. So I'm looking for sulfate here, which is SO4. So H2SO4 is my final answer there. Hopefully these went well. Hopefully you feel comfortable working backwards as well with writing your formulas for the acids when given the names. You'll be asked to do both, name to formula or formula to name. Great. Okay, another word you'll see, and I want you to write this down in your notes, is the word protic. Protic stands for the number of H's. So all acids are protic because they all have H's. That's like what makes an acid an acid. You have to have a hydrogen. If you're monoprotic, mono means one, you got one proton, one H. Diprotic means you have two H's. Triprotic means you have three H's. So for example, HCl would be monoprotic, but H2S, hydrosulfuric acid, that'd be diprotic because it's got two H's. Good with protic? Nope. Let's talk about bases. Now, we started yesterday off with bases. Hopefully you were able to figure out the rules because it's just regular ionic naming principles here. The one exception, and this is what you're going to have to memorize, NH3 means ammonia, which if you remember anything from biology, they talked a lot about NH3 ammonia. It's big in plants, in nitrogen fixation and stuff. Currently, I've got a plant in my house, nitrogen fixing away. It's blooming, or just finished blooming. It's probably going to start dying right now. So, fun facts about Mr. Smith. I got an amaryllis in the house, which is a type of flower. So here are some examples of bases. Yep, so we got LiOH. We know it's a base because it has an OH here. Li stands for lithium. OH stands for hydroxide. So to name this one, lithium hydroxide. That is the name. Pretty cool. For FeOH3, this is one I put on the quiz. It's supposed to be tricky because Fe is iron. Now, iron can be 2+, or it can be 3+. So the answer here we want is iron 3 hydroxide. Since iron can have more than one oxidation state, remember we call that a multi-charged metals. If there was a 2 after this OH, that'd be Fe2+, or iron 2. But since there's a 3 after this OH, since we needed 3 hydroxides to make FeOH, in parentheses 3, that means that it's iron 3 in this case. For NH3, we would call this ammonia. Yep, you just kind of have to know that one. And then calcium hydroxide. Calcium has a charge of 2+ always. So it would just be CaOH in parentheses 2. Notice how I did not write calcium as calcium 2 hydroxide. That would be incorrect. Iron 3 hydroxide is correct because iron could be a 2+ or a 3+. Calcium, its only charge is 2+. If you look on the ion list on the back of the periodic table, you'll see calcium only has a 2+ charge. If you look on the ion list on the back of the periodic table, you'll see iron has a 2+ or a 3+ charge, multiple charges. Calcium only's got one. It's only got that 2+ charge. So that's why it's just calcium hydroxide here versus iron 3 hydroxide up on the top here. Hopefully that makes sense with bases. The nice thing about acids, you won't have to worry about Roman numerals at all. So that's kind of fun. Here are some more questions asking you to name acids or bases. So can you tell when it's an acid or when it's a base? Here we go. Hopefully you pause the video because you need more time, but I'm going to go over them. So the first, third, and fourth examples are all going to be acids because they all start with H. So this first one here, ASO3, that is arsenite. So we're going to change that to arsenous acid. MgOH in parentheses 2. Mg only has one oxidation state. It's always 2+. So it's just going to be magnesium hydroxide. Cn is cyanide. So this is going to be hydrocyanic acid. I'd remember you had an ic and a hydro. ReO4 is parenate. So HReO4 would be paranic acid. Kind of cool, huh? Great. Here are some more questions asking you to go the other way. So go ahead and try these as well. Here we go, writing formulas for acids or bases. You'll notice that we only have, once again, one base here, and that's ammonia. Ammonia is NH3, fun fact. Hydroiodic acid is going to be HI, because hydroic, that means we're dealing with iodide. Iodide is just I1 minus specifically. Ammonia we said was NH3. Tetraboric acid, so we're looking for ic goes to 8. We don't have anything with tetra, so tetraboric or tetraborate must be the polyatomic ion we're looking for. Tetraborate is B4O7, fun fact. So that might have been difficult to find in your periodic table, but it is there. B4O7, tetraborate. And it's a -2, so I would have 2 H's in front. H2B4O7. Phosphorus acid ends in OUS, so that means we're changing it to ite. So we're looking for phosphite. Phosphite is PO3, 3-, so it'd be H3PO3. So once again, at the start of all this lesson, I told you guys these are the 3 rules you're going to need to know about acids. Acids always begin with an H. For bases, there's one rule. You just name them like an ionic compound. There's one exception. Ammonia is NH3. And bases are formulas that always end with an OH, unless, of course, you're ammonia. Hopefully you have these rules. Hopefully you understand how to use these rules. If you don't, reach out to me. Ask a question. I'm here to help. Hey, guys, thanks for being such a patient audience. I miss you guys so much, and I hope you have a great rest of your day. Thanks for tuning in, and take care.